All right, so we want to see, is there an association or not between the years and the number of people who would say, or the proportion of people who would say yes to this question?
Yes, there is. Yes.
We certainly believe that. Why do we believe that? Well,
I hope that there are less sexist.
we need to write and test appropriate hypotheses here. So our null hypothesis, there are two different ways that you can write the null hypothesis for these. One is you can talk about the slope, beta, and then define what it is. Or you can simply say there is no linear association between these two variables, or there is a linear association between those two variables.
So you do that because it's easier.
I typically do that. I do both, just so that I'm used to it. But yeah, so you could say there is no, that's going to be remember the null hypothesis, there's no relationship, no linear association between the year and was it a proportion of people? Please look back at the top of the stem of the question.
I don't think so. Percentage.
The percentage? Okay, percentage proportion. Thank you. But I'll use whatever they said. The percentage of people who answered yes to the question The other way you could do this, you could just say beta equals 0.
What is beta?
We have to define that in just a second, and we will. She rolled her eyes. And the alternative hypothesis is there is a linear association. Between the year and the percentage of people who answered yes to the question. So you would say beta is not 0. Where beta, I'm out of room, so I'm going to write it up here. Where beta is the slope of the regression equation predicting the percentage who answered yes to the question and from the year. It would be slightly shorter to do it with the slope. I don't know how likely it is on the AP exam that you will be given this part, because you can calculate both of those from this part.
What are those represented?
I'm sorry?
What are T and P represent again?
That's the t-value.
Oh, okay. And what's P's the p-value?
P is the p-value.
All right. Whoa.
No way.
So the nice thing is they almost always give you the standard error, and you can find the t-value just by taking the 1.109637 and dividing it by the standard error, and that gives you the t-value. So even if they give them to you, you should talk about them in your analysis of what's going on. So t is equal to 15.12, and with how many degrees of freedom does this have? Well,
1937.
A lot. Just 15.
14.
it tells you in the problem how many years they picked out.
14.
It was 14 years.
Well, it's 16 years, but it's in.
Oh, it was 16 years? All right, so with
Why
the
was it
number,
-2 instead of -1?
because you do slope and intercept. So there's two variables that you're finding, so we subtract 2.
I asked that last time we did this problem.
Pardon?
I said I asked that last time we did this problem.
Yep. And with 14, the degrees of freedom is equal to 14. P is equal to 0.000. Did it give us 4 decimal places? 0.
Why does it matter if they're all 0?
Not really, it doesn't.
We just put equals 0. Would you count that?
I'm a huge meanie.
Yeah.
Which is less than 0.05.
Is this all part of C?
Pardon?
Is
Yes.
this all part of C?
Yeah, this is all part of C. So what do we do?
We reject the null.
So we reject the null.
Reject the null.
There is statistically significant evidence to conclude that the year and the percentage of people answering yes to the question are associated.
That's what I said.
And part of it for me on that, I kind of have the same feeling that you do about that, honestly. When you look at those, if you look at a scatter plot and you look at the residuals, you're already convinced that there's some sort of linear association, or you're convinced that there probably isn't one. So going through a whole significance test to show that there is feels like overkill to me. Now, the next question is a good question, though. So the next question is to give a confidence interval for the slope. So what that is telling you is about how much per year is that percentage increasing? That's actually an interesting question.
Quantify the system.
Indeed. So find and interpret a 95% confidence interval for the slope of the regression line for all years. All right. So I'm going to do that up here where I have, so I can be looking at this. So remember that our confidence interval, in general, what is it that we do?
The statistic plus or minus the critical value.
In which case, in this one, what kind of a critical value are we doing?
Like count T.
So T star
T star,
times
the standard error,
so the statistic is 1.109637 plus or minus. So now we need to find T star for 95% confidence interval. So we will go to the distribution and do an inverse T. Now, it's a 95% confidence interval, and the way that the calculator does this, at least on mine, on the newer ones, does it give you both ends?
It gives you the, like, you can center it.
You can center it?
Yeah.
Okay, yeah, on mine it won't let you center it. So I have to do 0.975, or I could do 0.025. It turns out to be the same thing.
Well, you can't center it on inverse T.
Can you not? Okay,
Only on inverse norm.
gotcha.
Which is kind of stupid. If I do say myself.
And this is 14 degrees of freedom, right?
Boop up. Boop up.
So our T star value is 2.1448. I think that on the AP exam, they usually round up to 3 decimal places because that's what it gives in the table of T values. And the standard error was given to us someplace here. The standard error was 15.12. Oh, sorry, that's not the standard error. I was looking at the wrong spot. I was like, man, that's going to be quick. 0.07339. Ian, did you put numbers in already, or? Oh, I thought you were doing something useful.
Can
Okay.
you do the plus one? I'll do the minus one.
Pi, 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 pi. That's a lot of pi.
For the bottom, I got 0.952230128.
You know, the easiest way to get the top one is just to do second enter and change the minus to a plus.
Yeah, I just haven't got there
Wow.
yet. Is that
that great?
percentages?
Yeah. So it's only changing at a rate of, somewhere between 0.95% per year and 1.267% per year.
Well, I thought that was people at first. I was like, not even a whole person per year.
Yeah, but I mean, it's a little over 1% per year. It's not very quick. But I would imagine that the same is true if you were to somehow be able to track racism. Probably changes about the same way. I mean, it's glacial.
Maybe not for presidents though.
Pardon?
And maybe not for presidents though.
I think you'd be surprised.
Yeah.
Do you? Okay. That question. This is the. What is it? The windows and was it doors and wheels? So in the United States, yeah. Do you think that there are more people who would not vote for a woman, or more people who would not vote for someone who was black?
A woman.
I think there'd be more people who would answer no, I wouldn't vote for a woman, and then yes, I would vote for somebody who's black.
Because it's worse to sound racist
Yeah.
than it sounds sexist. I agree.
Or at least there's religious justifications for not being a woman, and there's just like not that many religious justifications for being racist.
Yeah.
Also, we've had a black president, but not a female president. Very true.
I sometimes wonder, like for Obama, how many people didn't vote for him simply because he was black? I mean, that was the deciding factor.
But I wonder, like,
for women to like the other way, how many people would vote for a woman just because she was a woman?
Well, yeah, and you can do it the other way around for racism also. I voted for him because I wanted to have a black president. I'm like, okay, there needs to be more reason than that. On either way.
Next time we should do a study to see how many people wouldn't watch NFL announcers if they were women.
All right, any questions?
Nope.
Okie dokie.